because that's really important.
My job is working on making solar panels more efficient, affordable, and sustainable. My name is Xiaojing Hao. I'm a Scientia professor at the UNSW. The most used solar panel today are silicon. They actually works very well. But the thing is, they can only use part of the sunlight efficiently.
We see some dead area.
You can think of sunlight as the multi-layers of different energy, like the different colors in the rainbow. But if we can think of the silicon as a sponge, silicon can only absorb part of the layers. If we can use two sponges, the top sponge can absorb the higher energy light. The lower sponge can absorb the lower energy light. This is exactly what the tandem solar cell going to do. So for the current silicon solar cells, their efficiency just about 27%. It's so close to approaching their theoretical efficiency limit. For the tandem solar cell, it can go beyond the 30% already. And in the future, I believe it can go to beyond the 40%. For the top cells, we want the top cell to pair with silicon. To pair with silicon means we need to have the similar properties to silicon: earth abundant, non-toxic, and last long, like cassette, making from copper, zinc, tin, and sulfur. So now sometimes people ask me, how many kids do you have? I have 2 kids, but I also have another one, cassette. We also invented a technology. That's what we call the TCA technology. That stands for transparent conductive adhesive. By using this one, we can easily stick the top cell and the bottom cell to form a tandem solar cell. The sodium and also the oxygen move from the bottom. My team, we have already achieved the world record efficiencies in a number of top cell material candidates. For example, cassette, antimony chalcogenate, and perovskite. I want to say tandem solar cell is really going to open the uses in the places where space is limited. For example, building, vehicle, and even satellites. I'm incredibly honored to be elected as a fellow of Australian Academy of Science. I feel deeply humbled to be recognized alongside a lot of scientists whose work I admire. But this recognition definitely also to my field of solar photovoltaics, which is so critically important and particularly important to shape the future to the net zero.